Hello everyone, this is a video about the thought process behind the project. So the initial inspiration for this tool came from a video by Josik. His name is Oscar Gaia. This was the first time I saw anything about Houdini engine. And since then I planned to also do this as my first Houdini engine tool. And now this challenge was the deciding factor to finally do it, I guess. But obviously it's like way too far away from the topic, so I kind of pushed it towards the topic by adding the rain pipes feature, I guess. So yeah, I hope that counts. So right from the start I wanted to have some good control with the tool and especially speed. So during the process of creating it, I was constantly checking FPS and performance, constantly trying out the tool. And regarding the control, I already had the idea of being able to close the pipes manually. I had that idea in mind from the beginning. So this was quite useful, so I could already establish some attributes and groups in the beginning that would be useful later. But I actually first started with some testing. So I was testing different sweeps, like the casual sweep, I guess. The Polyframe Labs has a good node, I think, just to see how UVs behave and how I would handle the half cut, the pipes that are open. So at the time I was considering doing it before the sweep by having two different profiles. But when I saw the documentation about the sweep node, this picture here gave me the idea to do it with p-scale. I mean, it's quite obvious, but I actually didn't know it works like that. And yeah, this visualization decided it. So that was quite useful because it works really good, and all my other solutions were like really inconsistent. Another thing during the testing was how to bevel curves. I didn't know how to do that either. So I mean, it's quite cool. So you just have to select points as the group type in the bevel node, and then it works. I also wanted it to be like really game ready, really optimized. So I wanted to have the player collision generated. It just was supposed to be a really quick tool without any more work to it for the user. So yeah, the player collision in there, the LODs, which is basically just sweeping in different segment counts. And at some point it removes fixations too. Also, it obviously should be as low poly as possible. So I wanted it to be all connected. So not like multiple separate geometries intersecting with each other, like the separate pipe segments. To reach this goal, it was also quite handy to have the method mentioned earlier with sweeping with the p-scale. Because it would always stay connected. So yeah, that was quite handy. Also, yeah, consistent UVs was a thing. So I built a little tool to match the texture density on all the pieces. And generally throughout the entire process, there is like really one main thing that gives the result. So it's a lot just about a lot about groups and how they transform. And yeah, it's really important to look up old groups and see how they change during certain processes. And that was really useful to reuse most of these groups. And I think another different thing, it's maybe quite unexpected, but obviously it's quite difficult to sweep crossings. So I mean, that's the reason it's only a one-way curve, so to say. So you can't have actual crossings. But I mean, I needed some sort of crossings for this classic rain pipes look at the corners. So for that, I procedure modeled the crossings on the side, referencing parameters from the mainstream, and then scattering them on top on the corners where they're supposed to go. And for the vertex colors, again, it's really just the outputs of previous nodes. Like I've used a lot of the classic sub nodes, and most of them have like some really useful output groups. I used, for example, Polycard has. Polycard doesn't actually have output groups, but it keeps groups in a consistent pattern. So that's what I meant by being aware of how groups change throughout the process. But for example, like with polyfill, you have the patch. For polyextrude, you have a bunch of groups, and it's just about embedding the right information into the stream at the right time. And yeah, that's kind of how I got the vertex colors in the end. So this wraps up the kind of process during this project. I hope it helped a bit to understand better what's going on. And yeah, thanks for watching.